All right, we are on day 6 now. Last new bit of information for this unit is talking about scientific notation. So being able to go from standard notation, which is something like, sorry, my pen just disappeared on me, 100 over to scientific notation and vice versa. That's why there's a two-sided arrow. So how scientific notation works is you get your number, whether it be really large or really small, and then you make it so that only one digit is in front of a decimal. So it could be 1.2, it could be 3.486, but you only have one digit in front of that decimal. So that A term that I underlined has to be between 1 and 10, but it can't be 10. It's a one-digit number, and it also can't be 0. It just has to be some type of integer. And then you raise it to 10 to some power where n is an integer. So I might write 1,280 as 1.28 times 10 to the third, for example, in scientific notation. And we'll talk about how you get there. So with our powers of 10, if you have 10 to the second power, that's 10 times 10. It means multiply your number by 10 twice. So this is saying take 1.28 times 10 3 times, and that'll get you back to your original number. Now, from your day 4 unit, we know that that moves the decimal 1, 2, 3 when we were talking about the metric system. So 2 times 10 to the third is 2 times 10 3 times, which adds 3 zeros or gives you 2,000. Now, if you have a negative exponent, that means divide. You're dividing by 10. So 10 to the negative third, for example, would be 1 over 10 cubed, or 3 1 over 10s. And we also talked about this in the metric unit. That moves your decimal 1, 2, 3 to make it a smaller number. So you would get that 0.02. Okay, so continuing with the scientific notation, how we would write a number in scientific notation. So you take your number, and whether it's little or small, you move the decimal left or right to where you have one digit in front of the decimal. So again, if it's 0.000123, you would move it there. If it's similarly a big number, then you move it there. So both of these would have 1.23 as their numerical part. Then what you do is you figure out what power of 10 you need. Okay. So the sign of the exponent is going to be positive if you took a really large number and made it small. So this one would have a positive. It's going to be negative if you had a small number and made it bigger. So this one would be negative. So depending on how many decimals you moved it, that's the number of that power. And then if you want to go back, you simply move the decimal that number. And then always kind of check your answer mentally. If it was 1.23 times 10 to the negative 4, it should be a small number, somewhere in that range. So it's basically giving you an instruction manual of how many places you move the decimal. All right, so then if we want to convert standard to scientific, standard are all of these numbers here. First, pause the video and give it a try. Do you already know how to do it? You might be surprised. If not, watch a couple, pause it, try them. So I want only one number in front of the decimal. So I'm going to do this. And then I've moved it from there to there. So that's 3, 6, 8. And then positive or negative, I had a really big number. So that number is going to be positive. So I'm going to end up with a positive exponent. Contrast that to number 2. I know that I'm going to have a negative exponent. So 1, 2, 3, 4. I want to move it so I have one number times 10 to the negative 4 because I moved it 4 places. So this one will be positive. This one will be negative. This one will be negative. So this one becomes 6.4 times 10 to the 4th. 1, 2, 3, 4. This is 1.8. 1, 2, 3, 4, 5, 6. Starts to get a little rough there, but I know it's negative because I already wrote that it was going to be negative. So I don't have to worry about, oh gosh, I just counted all those zeros. I can't remember. And then this one is 7.5 times 10 to the negative 1. So then if I want to work backwards, if I want to convert scientific notation to standard notation, you move the decimal point as many decimals as in. If it's a positive exponent, it's telling you to make the number larger. If it's a negative exponent, it's telling you to make the number smaller. So that's how you would figure that out. So this one would be a very large number. I'm going to move the decimal to the right 6 places. I'm going to make it bigger. 1, 2, 1, 2, 3, 4, 5, 6. So that number ends up being 6,350,000. This one I'm also making bigger. 1, 2, 3. This one I'm making very small. So I know I'm moving it 1 here. So to move it another 9, I want 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my 10th and leave the 7. And then this one, I move it to 1 and then put 3 zeros. Okay. And again, you should definitely pause, try these out as you feel you have it. And then there were 3 more to practice. So these, so that you have the answers, again, pause it and try them first. But here's the answers for these. Okay. And then our last little bit is ordering from smallest to largest. So when you're going smallest to largest, it's a standard number line. -5, -4, 3, 2, 3, 6. It's just a regular number line. If you're -5, you're automatically smaller than anything else. So this -5 is already the smallest one because that power is what you look at first. All right, so that guy's gone. Then I'm going to look for any 4s. This 2.3 times 10 to the -4. Okay, what else? Next it goes 2, 3, 6. So I'm going to do my 2. And then these are equal. So if these are equal, get rid of that power and look at the numbers. 1.7 is smaller than 9.8. And then we finally finish with the 6. And that finishes off that section. Make sure to look at the learning skills so that you have the right thing. Make sure to keep up with all those as well. And that is all the new notes. The rest of the unit is going to be review and study skills, ways to study for that test coming up in year 154. So have a great day.